Okay, so the same questions I will solve in different manner. Let me raise. At a time I will know you will be given only 3 quantities and the rest you will have to find. Yes, this will indicate what we have done. This is the first method. In the second method, yes, suppose this figure, same figure, and suppose at this time I have only this angle measurement. So with the help of this, what will I do? I will measure the angles. So let me measure the angle. You should see it. So I will have to make like this. This is actually angle. It's appearing to be. Oh yes. This is 90 degree. This angle. Yes. After that, oh yes, this is. This one appears to be 45. Yes. And this side. All the three. If you know only 2, there is no need to measure the third one, because the third one you can calculate. So I have calculate. Suppose I with the help of this, I don't have any scale. Then what will I do? Sir, I have a triangle in which I don't know the length. I have a triangle in which I don't know the length is equal or not. Only I know this is one angle is 90 degree. This angle is 45. This angle is 45. Okay, let me draw somewhat bigger. This angle 90 degree. This angle 45. I don't know this length because we don't have any, and this obviously we will apply the first theorem, because at any time you should to know only two angles AA. So the third one can be applied, the third one can be found. Third angle A is equal to 180 minus of this 2 angle, sum of AA, this. So the third A is equal to 45. So this is the first theorem. Okay, so this is 45. Now with the help of 3 information, A or double A, suppose I have, this is the second, this was the first case and this is the second case. I have AAA or 3A. So can we find the S if we not measure any angle, any side? Because the 3 things I have made, 3 things means 2A and A, 3 things I have made. Can we find the sides with the any geometry? This is the question. Because I have another triangle, and suppose this is and this chota bhim and this is the bada bhim, and for this I will measure the angle. I will measure, I think this I have made this one, yes, and this is that. I have measured only 3 angles. So can we tell which is the actual triangle, this or this? This is also 45, and let me show this is also 45. Or you can you have measured it, you can check it. The angle is same. Angle is same 45. Yes, this is means same means is these are 2 triangles, but appears to be one. This corner. And this line will be parallel to this one. So that is chapter number 6. Okay. When I will measure at this corner, this is 90 degree. Earlier these two lines were just like, if I will slide in this way, you are able to see this line parallel to this and this is parallel to this. When I slide slowly, these two lines will coincident. Parallel lines were and coincident. Now this is 90 degree, yes, this and parallel. Okay, if I will measure here, this is what this. These are two triangles, but appears to be because angles are same. So now these are parallel. Okay, if I will keep here in middle, just I keep it here in middle. So are you able to see any similarity? Similar. These are similar triangles. No, these are not parallel. But if line parallel is not parallels, it does not mean these are not similar. You have to change the orientation and the lines will be similar. At least one angle you should to measure one angle. Three types I have shown. This angle equal, so this will be parallel. This, so this will be parallel, and this. So in the chapter 6, I will teach much more about this. And this, this is this is what is the ratio between these two. Okay, let me draw here also. So if I will measure only angles, I will be confused. I cannot be confirmed that which was the means. I will say no, the triangle was a small one and that is the bigger one. Okay, if I measure this, so the angles will be same, again same. I have shown in the starting. Let's make right angle. Yes, these are parallel. This one in class chapter number 6. This was the figure. This was, or means you may say this was the figure. This line parallel, or you may say if you remove it, this was the figure in chapter number 6. This. In chapter number 6, theorem 6.1. What was the theorem? If all three angles are equal, in this the three angles are equal. The three angles are equal. You can confirm it. This is angle and this is parallel. So all the three angles will be equal. क्या हमको do we need to measure this angle equal or not? Actually, I have measured only one angle and confirmed these are parallel. So parallel means this angle will be equal to this corresponding angle. This corresponding angle, equal, theorem by theorem. But let me let me experiment. This is what you're saying. What are you looking? This parallel to this. And the ratio. What will be the ratio? These are in this. It has some problem. If it is not exactly 45 degree, then the things will not match. If some, I think the very rare difference is there. You are looking. So this will not be 45. Something is problem here. Okay, because no, this will not work in this way. Oh yes, this is the 45. Okay, now measure this one. Oh yes, this is 45 because this is 45, no problem. When you keep it in this way, this is again 45, but this line is not parallel to this. This is not parallel because this has come here. So this type of questions will be in chapter number 6. So let me come on my original questions. If you measure all the three angles only, so you would have this triangle, and this, all three triangles. So which one? So that is why it's in chapter number 6 it was three angles, means all the similar triangles, and you would have to confirm at least one side, at least one side. Okay, otherwise we will know the ratio. What is the ratio? Okay, let me tell. We will know the ratio but not exact side. What is the side? The ratio will be what? In chapter number 6, my first lecture. First lecture? No, in second lecture you will see the ratio I have taught in second trigonometry second. Okay, so I will show these two triangles and we will talk about the ratio, because we have measured the angles 90 degree, 45 degree, only angles. So we cannot be confirmed, because in these two triangles angles are same. This is 90 degree, this is 90 degree, this is the same, this one you can check, this, and this is for this. And you can place it here like this. This is parallel to this. Blue color, are you looking? When you will keep it here, this will be like this. This is parallel to this. And when you will keep it, I have not make any color. This one, this is parallel to this. Okay. So if you know only angles, so what can you know? This is 90 degree, this is 90 degree, and this is 45. So or no need to write 90 degree, only this is the symbol for right angle triangle. This is 45, this is 45. I have told you no need to write third angle. This is because in right angle third angle can be found, only two angles are very important. You will see here, whenever I defined in right angle triangle sin theta cos theta, I will focus on this angle, or at this time this angle, means not of this. Why? Okay, so this angle. Okay, so which one you are talking about, this angle or this angle? If I will get, I have if I ask to any student, go and measure the two triangles are there, and I will give them only this for the measurement. So they will measurement, yes, this is angles are same. They will come back to me, and when I will ask to him, okay, can you draw the triangles? So he will draw this, or between these two many triangles are there, because means he will say, sir, triangles was smaller. But smaller, how much distance? Because he has not measured. So distance may be, this may be just like here, this is 10 and 10. This is 10, I am not writing here, 10 and 10 and 10 root 2, and this is what? So 10, it may be 11 and 11 root 2, it may be 15 root 2. He will tell you, sir, because he don't know the sides. He will, what can he draw the triangles, exact triangles? No. For that he has to measure at least one side also, at least one side, the two angles and at least one side. Two angles, just like at least one side is very important. So when this come congruence, until you only two angles or three angles, the triangles are similar. When at least one sides come, the congruence, the same triangle should be there. So at least one side should come. That is the reason. And before that, the two angles, all three angles, no sides, mean thus triangles are similar. The ratio will hold, and this ratio, similar means ratio will hold, and that is the ratio. This ratio is trigonometric ratio. And when ratio TR, and when at least one side and then two angles or one angle, means then it may happen that these sides, the three sides, no angle, we can calculate one side and two angle. So that will be, two angle means all three angles, that will be In another class I will teach you angle, side and angle. This is, and in trigonometry chapter number 9, most of the questions you will saw this angle, side, angle. Because I am teaching trigonometry, so many things are there now for the similar, and this for the at least one side will come, then you can draw congruent, mean two copy photo, congruent triangle, this one. So from this trigonometrical ratio can we find the other sides? This is the trigonometry. Similarity with the similarity, but for the similar triangles, what we will take as a ideal, just like 1 kilogram, when we measure, suppose two students are there, this is of class first student, this is of class 6th student, 10th student. So students both have same eyes, same nose, same thing, but it is will be of smaller, and its nose, mouth, height, everything will be larger. So the ratio, this in our face ratio is very important. Suppose one eye is more bigger and the another one small, so the face will be disturbed. The ratio of the sides 1:1. The ratio of the sides 1 is to this. No sir, this is round and this is this. Okay. Suppose means ratio means equal and greater, little. Okay. So this is side. I am telling you this is 10, only 10, and it is. Let me measure now. Let me measure what is. This is what? This is 1 and this is this is not 30 actually, this is 29 and something different. Okay, but I have cut 30. Why it has 29? This is 1. When I have cut, because I want to make 3 times. Okay, so suppose take it 30, 30, 90 in this. So this will be angle, side, angle, angle, side, angle. And you can now if he measure any one side, so either 10 or 11 or 12 or 30, but I have taken 2 triangles. So only with this 3 information, what? Angle means right angle, this angle, right angle, and this one angle, and this side, angle, side and angle. We can measure we can tell all the sides without measurement with the help of this ratio and the trigonometry. That is the concept. But for that we have to make the just like for the measurement we take 1 kilogram, and this is 4 kilogram, 5 kilogram. Suppose you measure, you weight 4, 5. So that's are the ratio with compared to that 1 kilogram, 1 meter. That's are called standard. Standard 1 kilogram, where it is standard 1 meter, where it is standard 1 second. So standard is defined, and for that triangle, so this is 10 because 45 the angle is, first we will measure the angle for any triangle. First we will measure the angle, then second, if the angle is same, then apply the second concept. If the angles are same, so the sides will be same. The second, angles and side and angle. In class 11th, this side angle concept will be sine formula. Sine A upon A opposite sides is equal to sine B upon B is equal to sine C upon C. That will be, means if the angles are equal, then opposite sides will be equal. You will read in class 11th sine formula. Note it. In trigonometry, these things, if the angles are equal, then opposite sides will be equal, is written in the form of sine formula. Sine A upon A and sine B upon B. Okay, that will be taught in class 11th. So this is 45, this is 45, so 30, 30. And after that, the third is Pythagoras theorem. Pythagoras. So this is 30, this is 30. You will find this is 30 root 2. And similarly, 10, 10, 10. 10 and 10 root 2, which I have told you this earlier also. So, but what we will take 1 kilogram, not this triangle, not this triangle, we will take smallest triangle for 1 kilogram. I have not made 1 kilogram, smallest, 1 and 1. 1, this is 1, this is 1, and this will be root 2. This is 1 kilogram, just like 1 second, 1 meter. And this is the 10 times of that, this is the 30 times of that. So this is 10 times, this is 30 times. So many things, 30 meter may be there, 30 kilometer may be there, 30 miles means the times. This is the actual 1 unit, 1 and root 2 squares of any square of which I have taught in the last class. This is 1, this is 1, so this will be root 2. But how the trigonometry will come here? Trigonometry. So let me show. So these are three theorem I have used. One, the first I will find the angle. The second, side angle side, or this will be also. So I have found this 30, and then Pythagoras theorem 30 root 2. All three sides have been found. Okay. Now let me use the trigonometry now. To find these all values. This is not, you don't know, this is you don't know. And for this also, you know any side, one side, any one side, two angles. But this is not correct. This should be 10. So I have taken 1. So, you know, that is what it is called. If this is the ratio of, that is why the definition entered. This is, if this is 45 degree and this is right angle triangle. So for this angle sine 45, this will be base and this will be perpendicular, and the hypotenuse just opposite to the right angle. Hypotenuse is fixed for this angle. This will be base. So sine 45, if this is 1, this is 1, then this is under root 2. So sine 45 is equal to, if I have to know, if I have to find this one, sine 45 is equal to this. So cos 45. If you have given this 30 now, so with the help of this you can find this. So I have told you in the class second class, cos 45, only two things are there. Cos 45 base upon hypotenuse, and base is 1, hypotenuse root 2. So this is the ratio, this to this. So whenever you will be given 10 times or 100 times or 50 times, only distance will be given 10. So what will you do? So sine 45 is equal to, this is sine 45 cos 45. If you have to find this hypotenuse, so you can use sine cos 45. Cos 45 for this is 30 base and hypotenuse. So 30 upon hypotenuse, this. Now you will write cos 45 value, this 1 upon root 2. This is the ratio, and this is 30 upon h. This you can calculate h, this. So h will be 30 into root 2. If you use, because base into hypotenuse, if you use sine 45, so sine 45 for this is the base and this is the perpendicular, this one. So for the sine 45, what is sine 45? Because now 30 root 2, you have known this. So no need to use Pythagoras theorem, no need to use opposite angle side wide, no use. Only this about this. Sin 45 is equal to 1 upon root 2. So 1 upon root 2 is equal to this upon this. So 1 upon root 2 is equal to this, I don't know. So this is x. So x upon 30 root 2. This, and you can find, root to root 2 be cancelled, x is equal to 30. There is another method. This I have used sin 45. This was sin 45, this was the cos 45. To calculate base and this and this perpendicular, you can use tan 45 also. Tan 45 perpendicular by base, and that was 1 upon 1 means 1. So similarly, this upon this, x upon 30, tan 45, 1. So in the directly you will get, no, sin 45 you can use tan 45, okay, I have told you, tan 45 x upon 30, and tan 45 की value 1 is equal to x upon 30. So x is equal to 30. This means, we can use sin, cos, tan, and most of the times you will use tan in the chapter number 9. Why it is? Because in the trigonometry, most of the times you will see this is the height and this is the distance, and most of the questions will be what is the height and what is the distance. No hypotenuse will be found, no will be asked, very little chance is there. Whenever the hypotenuse will be there, you will use cos and sin, but until most of the times you will be asked height and distance, so tan will be used in chapter number 9. So this was